This week at NASA. A full-scale test version of the Orion spacecraft got the once-over from visitors to Huntsville's U.S. Space and Rocket Center. It was Orion's third scheduled stopover on its cross-country journey from White Sands, New Mexico, after similar stops in Oklahoma City and Dallas. Not only were museum guests able to meet Orion and Space Launch System team members, they also could sign their names to a piece of flight hardware.
It's a very unique opportunity for the folks here in Huntsville to see the program that we're off developing for the next generation of space exploration that NASA is working on.
The Orion model's final destination was the Kennedy Space Center. There, it'll be one of several used by NASA to test and develop the future spacecraft. This multi-purpose crew capsule and the SLS's heavy lift launch vehicle will enable deep space human exploration missions beyond low Earth orbit. Orion's first orbital flight test is scheduled for 2014. Responding to public demand, NASA has created a companion image to its new Blue Marble picture of Earth in stunning high definition. Blue Marble 2012 is a composite image captured during 6 separate orbits by the Suomi National Polar Orbiting Partnership Satellite, or Suomi NPP. The separate swaths stitched together to form both of the new Blue Marble images were taken by the satellite's Visible Infrared Imaging Radiometer Suite, or VIIRS instrument, over an 8-hour period on January 23rd. The original Blue Marble was photographed by the crew of Apollo 17 as they traveled to the moon in 1972. Some more eye-catching imagery from another NASA science mission, the MoonCam camera aboard Ebb, one of NASA's Twin Gravity Recovery and Interior Laboratory, or GRAIL spacecraft, has returned its first unique view of the far side of the lunar surface. MoonCam, for Moon Knowledge Acquired by Middle School Students, will be used by students nationwide to study lunar images. In lunar orbit together since New Year's Day, Ebb and its twin Flo have been collecting data to create a gravity map of the moon. At least one object rover Curiosity is slated to photograph on Mars later this year will be immediately recognizable to most, if not all, Americans: a Lincoln penny. This 1-cent piece, struck in 1909 when the coin was first issued to commemorate Lincoln's 100th birthday, is on a smartphone-sized plaque attached to the rover. When the Mars Science Laboratory lands in early August, a camera at the end of the rover's robotic arm will use the penny to help its calibration. The Mars Hand Lens Imager, or MOLLE, will show details of Martian rocks and soil so tiny that the calibration target includes reference lines finer than a human hair.
We can position the camera up next to a rock or some soil, and we can take pictures of it like close up, or we can pull it back and we can take pictures of a broader scene, the landscape. We can even look back down on the rover itself.
Curiosity also carries 4 other science cameras, a dozen black and white engineering cameras, and other research instruments. MSL will deliver Curiosity to a landing site on Mars known as Gale Crater, where the rover will conduct a 2-year investigation of whether that area of the red planet may have ever sustained microbial life. Administrator Charlie Bolden headed a NASA delegation visiting this year's White House Science Fair. The annual event, held in the East Wing, highlights and applauds student excellence in science, technology, engineering, and mathematics, the STEM disciplines. NASA has developed a wide variety of STEM education programs in support of the President's Educate to Innovate campaign.
Roger, Southwest 23 to 600 knots.
Aligned with NASA's STEM education mission is a newly released game app with an air traffic control theme developed for Apple iPhone and iPad devices.
United 74 to 600 knots.
The Sector 33 application challenges students in middle school and above to use basic math and problem-solving skills. The player acts as an air traffic controller of a portion of Nevada and California, guiding airplanes' paths and speed to safely reach specific spots in the sky in the fastest time possible.
What's been fun about working on this project is not only exploring the world of mobile apps, but tying education into the game. Students can't just video game their way through these problems and solve them correctly. They actually have to understand the mathematics.
The latest edition of NASA's Spin-Off is now available. The annual publication follows the journeys of 44 innovative technologies, from their origins in NASA missions and programs to use in commercial products and practical benefits to society.
Over the years, NASA spin-offs have generated billions of dollars of revenues for our partner companies, created tens of thousands of jobs, and saved hundreds of thousands of lives.
Your spin-off is available online at spinoff.nasa.gov. Ever dream of sending a satellite into space? NASA is seeking proposals for flight demonstrations of small satellite technologies in hopes of increasing the technical capabilities and uses for this emerging category of spacecraft. Small satellites typically weigh less than 400 pounds and are generally launched as secondary payloads on rockets carrying larger spacecraft. They include the softball-sized CubeSats, which can carry small payloads and even smaller experimental spacecraft. Explore the possibilities at www.nasa.gov/OCT. In recognition of the contributions by African Americans to the cause of space exploration, This Week at NASA profiles Larry Clyat, aerospace engineer at the Dryden Flight Research Center.
Aerodynamics was fascinating to me, just the philosophy of aerodynamics, and that led me to aeronautics. And of course, the faster things go, the cooler it is. My name is Larry Clyat. I'm an aerospace engineer at NASA Dryden Flight Research Center. I work in the research aerodynamics branch, doing mostly supersonic research on supersonic flight, specifically sonic boom research. Sonic boom research is towards the ongoing effort to mitigate the sonic boom to allow over-the-land supersonic transportation for civilians. Both of my parents were in the Air Force, and as far as I can remember, the day my mom and dad brought me home a model toy replica of a B-2 bomber was the day I first got any interest in aeronautics or aerospace, period. I became a graduate student at Georgia Tech, and there decided to do a co-op rotation somewhere. The first place on my list, of course, was NASA. You know, everybody knows about this big centers, Johnson's, Kennedy's, and everything, but found out that there was a center that actually specifically did what I was wanting to do. My focus at the time was high-speed aerodynamics, which is aeronautics, and Dryden did just that. NASA Dryden, this is NASA ground. I'd like to know whether you had any fuel left for perhaps a Foxtrot run. Just this past year, I was a principal investigator for the Whisper project on the community response tests for sonic booms.
In that time frame, we tried to do a range of sonic booms. Not only in that range, but we also tried to start with you a little bit with some louder sonic booms.
NASA 2, this is NASA ground, heard boom on the ground.
So it was really fulfilling to see it out, to see it to its end, and to see how successful it was. One of the things that brought me here is I wanted to be an innovator, and I think that nearly anybody that works at NASA kind of keeps their mind open to pursue goals and tasks that no other company is doing, no other agency is doing. So if you keep an open mind, and if you have the desire to work outside of the box, not just think outside the box, but to do things that literally no one else is doing, and I think that's important.
3, 2, 1. Ignition and liftoff. Discovery now on its way to service NASA's Hubble Space Telescope.
15 years ago, on February 11, 1997, Space Shuttle Discovery lit up the pre-dawn sky at the Kennedy Space Center to begin STS-82, the second planned servicing mission to the Hubble Space Telescope. During the almost 10-day mission, astronauts Ken Bowersox, Scott Horowitz, Mark Lee, Steve Hawley, Greg Harbaugh, Steve Smith, and Joe Tanner upgraded Hubble with new imaging devices, including the Space Telescope Imaging Spectrograph, or STIS, an instrument designed to seek out supermassive black holes, and NICMOS, the Near-Infrared Camera and Multi-Object Spectrometer, which astronomers would use to capture near-infrared views of the universe. Discovery and crew landed safely at KSC on February 21st. And that's This Week at NASA. For more on these and other stories, or to follow us on Facebook, Twitter, and other social media, log on to www.nasa.gov.